So, hello guys, today we are going to discuss this question, fruit in baskets. So this is um, a Google interview question which I found in the Explore card, um, Google Lead Code Explore. So this is for the Google, um, and so we are going to today solve this fruit into baskets problem. So one of the main thing which I found here in this question is that I'm not able to understand the question correctly. So I'll be making spending some of the time in um, going through the question and um, helping in understand the examples here. So the question says is that we are visiting a farm in which all the trees are in a single row, arranged from left to right, and trees are represented by the integer array fruits, and fruit I means the type of fruit on the ith tree. It's a type of fruit. For example, uh, we can think of something like that 0 is apple, then 1 is banana, then 2 is pear, 3 is peach, 4 is guava, or something, some sort of things, right? So now the question says is that we are only given two baskets. Each basket can hold a single type of fruit. So for example, we have two baskets. This is basket 1 and this is basket 2. So this basket 1 can hold only bananas, that is, it can hold all ones, it cannot hold two. That's an important point, right? Same type. And basket 2 can hold only one type, that is only threes. And if we go for 4, this becomes wrong. So only threes. Only one type of fruit each basket can hold. Now next, starting from any tree of your choice, you must pick exactly one fruit from every tree. While moving towards right, the picked fruit must fit in one of the baskets. So we can start from any of the index, that is either we can start from 2, either we can start from 1, but we want to get the maximum number of fruits out of it. So let me walk through these examples. So this is the first example on the lead code 121. Its output is 3. So let's see how it is. So we have, let's take the basket as basket 1 and basket 2. So initially from starting at index 0, I placed fruit type 0, fruit type 1 in basket 1. So the count in the basket 1 is 1. Then at index 1, I placed fruit type 2 in basket 2. So the count of basket 2 is 1. And at the index I equal to 2, I again placed the fruit 1 in basket 1. So count becomes 2. That means the basket 1 has two fruits of type 1, basket 2 has one fruit of type 2. Hence the total count is 3. Let's go to this example to understand it. So this is also the example given here. So now we again have the two baskets, basket 1 and basket 2. So we start from this fruit, we place in basket 1. Then we reach here, we find that basket 1 is already filled, we place it in basket 2. Then we reach here at index 3. Now what happens is we find that both baskets have the different types of fruit. That is, basket 1 has type 1, basket 2 has type 2. So we cannot place this 3 into any other basket. So what we do is we just count the total number of fruits in it. So count is 2, that is 1 and 2, and we drop one of the fruits from basket. So I dropped this one and I placed fruit type 3 in basket 1. Now I again go to this one. So this type was already in basket 2, so now the number of fruits become 2. Then again this was again in basket 2, so number of fruits become 3. So total count is 1 plus 3, hence it is 4. So there can be like, I think you got the question. So if not, just try to go through this question by your own. So let me just walk through go through this example for you again. So here we have the two baskets. So if we place 0 in basket 1 and 1 in basket 2, so the count is 2. Now when we reach index 2 here, we find that the basket 1 is having 0 type and basket 1 is having 1 type. We cannot place 2 in any of the baskets because every basket should have the same type of fruit. So now we have to drop either 0 or 1. So let's say that we have dropped 0. Then we will place 2 in basket 1. Then again we'll play 2 in basket 1 again. So total count becomes 3 here. Okay. So now there can be two approaches to it. So first approach is the brute force approach. So in brute force approach, what we can do is, for example, if this one, we can have two for loops. In the outer for loop, we'll just stick to this one fruit, and then we'll just go to the other elements till we find the third different element. And then we'll stick to this one, and then we'll go to all the elements till we find the third different element, and so on. But this will be a O(n) square solution. So till we find the third element. The other approach will be the sliding window approach, whose time complexity would be OMN. So I'll just explain the time complexity here as well, but let's see how this sliding window approach works. So let me take the example of this one here. So we have the fruits here and we have the indexes here. So we'll be taking two baskets, basket 1 and basket 2, and we'll be taking the count inside the baskets, that is CB1 and CB2. And this is the count, which is the count of the total number of fruits in both the baskets. So this will be what we'll be returning as answer. So at index 1, we have fruit 1. So we'll place it in basket 1, the count will be 1. And index 1 will have fruit as 0. We'll place it, so we'll check that basket 1 is empty. No, it is not. So we'll go to basket 2, we'll place it 0 here, and we'll make a count 1. Then in index 2 we have fruit 1, so we'll see that either basket 1 or basket 2 has fruit of type 1. Yes, it is. So we'll place uh, like we'll increment the count of basket 1, that is we'll place the fruit in the basket 1 only. Then at index 3, we have the fruit as 4. So we'll check whether 4 exists in basket 1, no. Whether 4 exists in basket 2, no, because it is 0. So we have to empty any one of the basket. So before emptying it, what we'll do is we'll take the count. So present count is 2 plus 1, 3 fruits, right? So we'll take count as 3. But now the question here is, which basket should we drop? Right? So we will drop basket 2. Why? Because the previous fruit is basket 1 and we already have one fruit in the basket. So we'll drop basket 2 and we'll keep basket 1 as this. But the point again, the very interesting point here is we cannot keep count of basket 1 as 2 because the question says we have to find the consecutive fruits. So count for basket 1 was for these two, right? But now we are at this index and there is another fruit in between it. So we will, what we'll do is we from this index, we will at the by going back, we'll count how many consecutive fruits of type 1 we have. So we'll have only one. So we will keep the count as 1. So this is one of the twist in the question which we need to understand going back. And the new fruit which you have to place in basket 2 is 4 and its count will be 1. That's fine. Now we'll go to index 4 whose count is 1. We'll check that whether 1 exists in basket 1 or basket 2. Yes, it is in basket 1, so we'll increment its count. The count of basket 2 is same. Then we'll go to index 5. So index 5 is 4. We'll check whether it exists in basket 2, basket 1. Yes, it is in basket 2, so we'll so its count is 2 again, so we'll increment its count, that is we have two fruits of type 4. Then we'll go to index 6. So at index 6 we have 1, so we'll see whether 1 exists in basket 1, basket 2. Yes, it exists in basket 1. We'll increment the count, it becomes 3 and its count is 2 only. Now we are at 7, so we'll see we have a fruit of type 2, so we'll see whether it exists in basket 2 or basket 1. So now in this case it doesn't exist in anyone. So before changing, let's take up the count. So count is 3 plus 2, so we have 5. Now if the new fruit doesn't belong to any of the basket, so what we can do is we can drop uh, any of the basket. So we'll drop this one, let's say basket 2 basket 1 we dropped, and we'll make the count as 1 again. Okay, we'll make the count as 1. Now we'll go to 8, index 8. We have new fruit 3, so we'll check whether three exist in basket one and basket two, so it doesn't exist again. So again, if three we have found four, then we have to again repeat the process of finding the consecutive fruits backward. So now in this case, basket 2 count is 1, new fruit is inserted into basket 2 which is 3 and its count is 1. So finally we have the count is 2. So answer is 5 here. So let's go into the code to check how it works. So as I mentioned, we have taken two baskets, that is basket 1 and basket 2. And if we see here, the constraint says that fruit, the fruit type would be always greater than or equal to 0. So that's why we can take basket as -1 and counts as 0. So initially basket 1 is taken as fruit 0. Now fruit 0 is placed in basket 1 and count is done as 1. Now, for all the fruits in the basket, if now I'm starting from the second fruit, that is index 1. So if the second fruit is in basket 1, or second fruit is in basket 2, or basket 2 is empty, because basket 2 empty means -1. In that case, we'll go inside. If fruit exists in basket 1, then count of basket 1 is incremented. If fruit doesn't exist, um, like this may be the case that the fruit exists in basket 2 or fruit doesn't exist. In both the cases, we'll be incrementing the count and the basket 2 fruit is equal to the fruit only. Now the case is that we have a new fruit here. That is, the fruit doesn't exist in basket 1, it doesn't exist in basket 2, and both baskets are not empty as well, right? We are in mid. So in that case, we'll just take up the count of the present baskets, that is max of count and basket 1 count plus basket 2 count. And then what we'll do is, if the I minus 1 is equal to basket 1, so let me just go back to this again here. So what we are, so this situation, this one here is something here. So in this case, so we have 0, 1, 0 and we have a new fruit 4. So now in this case, we are just checking that if I minus 1, this one, this fruit, the where I have my mouse pointer 1, exist in basket 1. So at index 3 in basket 1 it was there, right? So in that case, we are changing basket 2. We are not changing basket 1 because we already have a fruit in it, right? So we are changing basket 2 and we are making basket 2 count as 1. So we have set this state. But now we have to count the fruit backward. That is how many ones are there. So in that case, we are doing this while we like fruits j minus minus is equal to basket 1, we are incrementing the count and then finally we are storing the count for basket 1 and similarly for basket 2. So if this fruit might have existed in basket 2, in that case I will be storing the new fruit inside the basket 1 and doing the same process here. And if the case is there that it's a completely a new fruit, for example in this case 2, so it's completely a new fruit, then we can place like the fruit I minus 1, this one in basket 1, and we can place this fruit in basket 2 or vice versa, and we are setting both the counts to 1. So there is no problem in placing any of like fruits in any one of them. So this submission has worked. So and this is yeah, this is the for the time complexity, this is a OMN solution. How? If we have n fruits, for example, the size of fruits is n, so we are traversing in the for loop till n, but now in this case, we are also using a while loop to check the same consecutive fruits. For example, I reached here, then I'm just traversing back to check how many continuous or consecutive type 1 fruits exist. And since these are in different if, else statements, so for the time complexity, we will take either one of them. So that's why it is OMN. For the space complexity is O(n) because there is no data structure or anything sort of that is taken. So thanks a lot, guys. Have a good day.